So today's lesson, before we start, today's lesson shouldn't be it is basically a big review from what we've done before, adding, subtracting, multiplying different polynomials. We will get into dividing polynomials. That is a little bit more difficult, but in my opinion, the more difficult, it's just it takes more time. If you can factor, then you can do this division. And when I say factor, I mean not complicated. This chapter is not over factoring, and so I'm not going to give you anything that's super complicated with factoring. Try to stick to the basics. But I think that's the hardest part of this, the factoring stuff. So before we start, I just want to do a really quick review on substitution stuff to make the same page. So obviously, if x is equal to 3, you plug that into this, you'd have 2 times 3 plus 4. So you put 2 times 3 is 6, 6 plus 4 is 10. Now, even if it's not a letter or a symbol, even if it's anything, smiley face equal to x plus 8, we still plug that in. And even if it's not just equal, like this one's equal to 3, even if it's still equal to a binomial, we still plug that in. So this would be 2 times x plus 8. That's something you guys hopefully remember from when we did systems this year. Number one, remember. So again, you plug the whole thing. Again, if the smiley face is equal to x plus 8, that means they are equivalent. It doesn't matter which one is which. So if I have a smiley face in there, I can take that out. I can put in the x plus 8, and nothing changes because they are the same. It's the same concept as if you had 10 and if you had 6 plus 4. They're equal to each other, so I could take out a 10 and put in the 6 plus 4, and it doesn't change anything. Now, the next one, even if we have xm like this, that's fine. If you ever seen xm, I can put in the 2x. This would be 5 times 2x plus 1. And lastly, the thing we're going to be using a lot today is if we have f of x is equal to 2x minus 6, that means if I have f of x plus 10, that means it's 2x minus 6 plus 10. Or if I have 3 times f of x, I'm going to have to use my HDMI cord because this is going to bother me. If I have 3 times f of x, it's 3 times 2x minus 6. Again, if f of x is equal to the f of x and put in a 2x minus 6, or I can take, I can put in the, put in an f of x. Not that we ever do that second one, but you can exchange those. What was the one? I'll have to think about that later. So the first two we're going to do are sums and differences of these functions. And again, this is the notation. Whoops, that line is very crooked. With this notation, it doesn't matter which way you write it, and honestly, usually they write it for you. So just make sure you know these mean the same thing. But again, all of these, I think this one's easier to understand. This one's a little bit quicker to write. It just means take those. Take in this one, and I add those. So again, don't make this harder than it is. I always use parentheses. X plus 8 plus 4x minus 9. Parentheses, but again, you've heard me say this before this year. I decide if they do need parentheses or don't, they end up messing things up. So I always just put them with the parentheses. So this will end up, you don't really need them. You can drop those on this first step. Then you combine the terms. 3x and 4x is 7x. 8 minus 9 is negative 1. So f plus g of x is 7x minus 1. Technically, I think it should probably be written like this. F plus g of x is equal to 7x minus 1. But I'm not going to make you guys do that. Is that been off? I just don't want. The next one is the difference. Again, don't make this harder than it is. The two ways to represent it are the same ways we just talked about. And this one is, make sure the order does matter on this one. So they have f of x minus g of x. So the f of x comes first. Minus the g of x. Again, they could do the opposite way. So don't just get used to going left to right. Make sure you're paying attention. Eventually, after lunch, I'll use that cable. circle the O before it pops up. You need parentheses with subtraction, because if you don't have the parentheses, that's the common mistake, is that people don't do it right with the parentheses. They just kind of like drop them, and you can't do that. All right. Give me 1 second. All right, sorry about that. So again, with subtraction, parentheses do matter, because again, the biggest mistake that people do with subtraction, and we had similar ones like this before, is students either don't put the parentheses or they just drop the parentheses like we did before, and they end up with negative 4x minus 9, and that's not going to be the case. That minus 9 is wrong. Remember, when you have subtraction, you have to distribute that subtraction to both of those. So it's 3x plus 8 minus 4x plus 9. That negative goes to that 9, and a negative make a positive, so that's got to be plus 9. That's the most common mistake. If this is multiple choice, you can for sure bet that's going to be one of them that's on there, one of the options. Then from here, you just combine your like terms. 3x minus 4 is negative x, or negative 1x. 8 plus 9 is 17. Again, technically, I should probably put f of x minus g of x is equal to that, but I'm going to save you guys some hassle with that. So we only have about 2 minutes. Actually, I'll just do this one for you since we only have a couple minutes. But again, same thing. It's subtraction. Again, this one should be J. Sorry that I messed that up. Put those together. We just subtract those. So 3n minus 5 minus 2n plus 3. So we have 3n minus 5 minus 2n minus 3. And negative 5 minus 3, 8. That's your answer. Fine, this doesn't really matter, but since I talk about it anyways, your variable is. So a lot of times we have f of x because you use x. If you want to change your variables to x, that's fine, but make sure you change all of them. Put f equal to 3x. So if you want to change them to x's, I don't care. Just make sure you change all of them. But that's what that means in the parentheses. That's just telling you what variable you're putting numbers into. Bell's going to ring in about a minute, but before you pack up, the product is the same thing. You're multiplying those together. So you'll take 3x minus 2 times 5x plus 4. That's just going to be 3x minus 2 times 5x plus 4. And we multiply those like usual. So 3x times 5x is 15x squared. 3x times 4 is 12x. Negative 2 times 5 is negative 10x. And negative 2 times 4 is negative 8. And your like terms in the middle, 15x squared plus 2x minus 8 is your answer for that one. So multiplication, again, don't make it harder than it is. You literally just multiply those out. Next one is 3b. Oh, this is supposed to be b. When you come back for lunch, we'll talk about the answer to that one. So this one, again, it says f times g. I made another mistake. I put g in here and it should be a b. So if you want to change that, but again, don't make it harder than it is. It's 3b multiplied by 2b squared minus 3b. Just make sure I put this one in here because some students do get confused. If I have 3b times 2b squared, 3 times 2 is 6, and then b times b squared is b to the third. Some people still get confused with that. 3 times negative 3 is negative 9, and then b and b is b squared. So, moving on, the one that's more, and I would say it's not that it's much more difficult, besides the fact that it's more work, it takes more time, and there's factoring in this one. So, for this one, I have the division style. So there's several different ways they could write it, as a fraction or like this, or I guess I didn't have this one in here, but if they had f divided by g of x that way, that would also work. But you start by putting your fraction. Would start. Now from here, the first thing I will tell you is you can't cancel anything yet. One of the common mistakes with this one is people try to cancel these x squares because eventually if you have the same thing on the top and the bottom, they cancel. So they try to cancel these x squares, but you can only cancel this multiplying. Right now it's x squared plus this and x squared plus this, so you can, if it was x squared multiplied, then you'd be able to. So if it's multiplication, you can. If it's adding, subtracting, you can't. So the way you can remember is we need to change that into multiplying. So those of you who are really good at factoring, you can just go ahead and put the answer. I don't care if you show me your work on this part. So if you know that it's going to be x plus 2 and x plus 5, I'm okay with that at this point. If you don't remember how to factor, I always do the x. 1 times 10 goes on the top, 7 goes on the bottom. 2 numbers that multiply to be 10 that add up to be 3. If you need a list of factors, you can, but it is 2 and 5. Now, again, I think we're getting good enough at factoring that some of you guys don't need to do that. And if you're like me, sometimes I will have to do it the long way, and sometimes I can do it in my head. It just depends on the problem. Just be careful whichever way you decide. I will never have a coefficient. I will not ever give you one that I think is that difficult. Pretty much ones like this that are difference in squares, I'll have a couple of those, and then a greatest common factor. But I'm not trying to beat factoring to death. We already did earlier. Same thing. Factors of 8 to be 6 are 2 and 4. This, now that it's multiplication, now if you have the same thing in the numerator and denominator, you can cancel. So for instance, x plus 2 and x plus 2 cancel. They're in the numerator and the denominator. And I don't think it'll help you guys, so I'm not going to get into it, but this is essentially the same thing as reducing a fraction. You can write a fraction where you write it as multiplication, and then the top and the bottom numbers cancel. You could think of it that way. So your answer for this one is x plus 5 over x plus 4. Now again, some students get super trigger happy with this, and they say, oh, the same thing on top and bottom, that cancels. And then over here we have x and an x on top and bottom, so they cancel. No, again, now we have plus, and you cannot do that if you're adding. Only do it if it's multiplication. So that is part of your answer. That is the biggest part of your answer. Now, I struggled whether I should actually go over this or not. So I promise if this next thing doesn't make any sense, this is one of those things that I've said before. If you're trying to get an A or like an A+ in this class, then yeah, pay attention, make sure you get this. If you're just trying to get like a C in this class, then this next thing, if you don't want to pay attention to, it's up to you. It's, in my opinion, it's not hard. It's just hard to remember at the very end. So the excluded values. Once you're finally done with this, there are a couple numbers that will not work for this. And those couple of numbers are the ones that make your denominator 0. Why you can't ever have 0 as a denominator. Talk to me sometime. We can look at it and we can talk about it. I don't think any of you guys are interested, and I don't think it's going to help you guys. So I'm not going to get into that. So the things that make your denominator 0, well, in this one, color, this part, let me get a different color. This part would be -4. So our x cannot be -4, because if it was, we'd have -4 plus 4 and we'd get 0. But what a lot of people forget about is you still have to go back to where you cancel. If you go back to the one you canceled, you still have to include that. So my x can also cannot equal -2. And again, the reason is because if you plug in -2 or -4 to your original equation, you on the denominator, you can have it. In case you want to do this, factor, because to find the zeros, it helps a factor, or you could even mark out a formula because you're going to have a factor anyways, but it's up to you. So after you factor, then it's the easy place to find to solve these for 0. But again, just make sure to remember, even the ones you cancel still definitely counts. That -2 has to be in there. And I imagine that I might include on the test, and if I do, I'll probably have something that says, don't forget your excluded values. Or I thought about having, I could put an extra credit, or not extra credit, a multiple choice question that says like, so here's this function, what are the excluded values? And have it all set up where it's already factored and stuff like that. Because it's nice. I want you to know the concept, but again, I don't want you guys to like beat your head against the wall and like hate your life. because of that. If you want to hate it for some other reason, that's on you. So go ahead, do 3 and 4 on your own. I will give you a heads up that number, and again, I tried to do this where there wasn't a ton of factoring. Like between these two, I could have made you factor 4 different things. Instead, this one's already factored. This one is a greatest common factor, so hopefully it goes quick. And this one's factored, and this one is a difference in squares. So hopefully that helps out, make it go a little quicker. But we will talk about those here in a second. All right, sorry if that was too quick, but my answers are up there. Again, don't forget, and this is one of the things that happens with factoring. So much of the trinomial factoring, so much of the ones we just talked about, where we use the x box or the x factor and all that, that I have students that literally get to this problem and don't know what to do. You just take out 4, so that would be x, and then 20 divided by 4 is 5. The 5's cancel. Both of these are examples of if in the numerator everything cancels, you need to put a 1 in there. You can't just have the denominator with nothing in there. So if everything in the numerator cancels, it's a 1. Technically, the denominator would be the same thing, but in the denominator, if you have a 1, that doesn't really mean anything. Just like 3 is the same thing as 3 over 1. In squares for a while, but I hope you guys remember that. Since x squared and 36 are both perfect squares, you can break that into x plus 6 and x minus 6. Because again, 6 times 6 is 36. Again, they cancel each other out, so there is a 1 left in the numerator. And then last but not least, again, your excluded values. You cannot get 5 for this one, because they cancel, but that doesn't matter. You can't have 5 for this, that gives you 0. And over here, you can't have positive 6 or negative 6. And if you don't remember, I think it's a very, in my opinion, a standard or typical thing. You have to do all the hard work to get that anyways. I just think a lot of people forget about it. So I will try to remind you if I put it on a test, I'll try to make it very clear. But again, there will not be very many of those. So last but not least, when we have these, when we evaluate these, there are 2 different ways to do this, and I still don't really know which way's better. I tend to do the second one more, but if I'm asking, instead of f plus g of x, I'm asking for f plus g of 7. Remember, if I have f of 7, that means I put 7 in for my f equation. We talked about that yesterday. If I have g of 8, I put 8 in for my g equation. That's what we talked about the other day. But if we have f plus g of 7, there's 2 ways to do it. One way is to add them together first. So 2x plus 5. X plus 5 plus 5x minus 10. And then when you finally do that, then put 7 in. Or this one where you put 7 in first. So you plug 7 into both of those. And g of 7 is 5 times 7 minus 10. And once you get those 2 numbers, you add those together. So I don't care which way you think is better. I personally do it the second way a lot, but that's up to you. Depends on the problem, which is easier. But to go back and finish these, I add these together. So we have 2x plus 5 plus 5x minus 10. So you can find out terms 7x minus 5. Once you finally have that, then you plug 7 in for that. 7 times 7 minus 5. That's 49 minus 5 is... And if you plug 7 in first, 2 times 7 is 14. 14 plus 5 is 19. 2 times 7 is 35. 35 plus... Sorry, 35 minus 10. Sorry, my handwriting is super sloppy. Minus 10 is 25. 19 plus 25 is 44. So it doesn't matter how you do it. I'm personally going to stick to this way just because I think doing every problem twice, I think it's probably a little bit boring and redundant. But again, if you want to add your equations together first, that's up to you. I think the second way is a little bit easier, getting harder problems with exponents and stuff like that, but I could be wrong. So I'm going to do the next quick just to make sure you have time for your exit ticket. But this one, the only difference is now we're multiplying. So again, for me, I'm going to plug in -4 to both of those. So J 4 is 5 times -4 plus 8. 20 plus 8, 12. Then plug -4 into my H equation. So that is 2. So -4 squared 2. The -12 and the 32, multiplying, so we just multiply those answers. Again, we did earlier. So 32 multiplied by -12. 32 times -12 is -384. Than the other, numbers in. I know there's a lot going on. I know it can be a little confusing, but as far as the math goes, it's not too bad. You just have to make sure you know where to plug those in and what you're looking for. Make sure you do your exit